page 634, I want you to highlight this. An absolute value in this form, does it make sense that you could have 0, 1, 2, 3, or 4 solutions? Okay, because graphically, remember graphically, whatever the d value is, that's a horizontal line. So if I had it right here at 4, it would hit the graph 3 times. I could draw it at 2 and have it hit the graph 4 times. I could draw it right at 0 and hit the graph 2 times. Or I could draw it up here and hit the graph 2 times. Or I could have that negative number and it would never intersect. So when we're solving it algebraically, we have to be aware that with an x squared graph, we could have no solutions, 1 solution, 2 solutions, 3 solutions, because sometimes if the parabola is above and only hit the x-axis once, it is possible that you could have 1 solution. So what we're going to look at next is the algebraic methods more. So we'll go to example 3. Right? What does an absolute value do? It makes whatever number's inside of it positive. So with an absolute value equation, there is always 2 possibilities. We have the possibility that the 4x plus 6 is positive, and we have the possibility where the 4x plus 6 is negative. You don't have to write that, for your notes right now, I think this is important. But when you show this on a quiz or a test, you can just draw your 2 arrows to set up your 2 equations. Sometimes I split them up with a line in between. If the 4x plus 6 is positive, do the absolute values do anything? No. You could just ignore them. But if the 4x plus 6 is negative, if this 4x plus 6 is a negative number, what does the absolute value do to that negative number? It makes it positive. Algebraically, how can you make a negative number positive? You can take that whole negative number and multiply it by a negative, then it would become positive. So it's important to know, what does an absolute value do? It makes something positive. What could be the possibility in a solving question? It could be that it was already positive, in which case the absolute value doesn't matter. Or there's a possibility that the 4x plus 6 is negative, then you'd have to put a negative in front to make it positive. Now we solve both of these separately, so I can combine my like terms, I can move my x over, divide by 3. So I get one possibility that x is 2/3. And distribute my negative. Again, I'm going to combine my like terms, so I can put my x's on this side. 5x equals negative 14. And x is equal to negative 14 over 5. Another thing you have to check in these questions, when there's an x on both sides, since you've got an absolute value on that side, does it make sense that after you do the absolute value, the left-hand side has to be positive. If x is positive 2/3, is 2/3 plus 8 a positive number? Yes. I'm just doing a double check. If I really wanted to double check thoroughly, I'd plug in 2/3 and see, does it work out perfectly? But right now, I'm just checking to see if it's positive. I was a little bit nervous about the negative 14 over 5, because it's a negative number and that I have an x on this side. Is negative 14 over 5 plus 8 positive or negative? How would you check? You need a common denominator, right? And?
I was just going to say that negative 14 is like a little less than 3.
Yeah, like you could estimate this. Yeah, this is a little less than, so this is like negative 3-ish. Is negative 3 plus 8 positive or negative? This is going to be positive. This is going to be fine. Or you could change the 8 to 40 over 5 with the common denominator. And then ask, is negative 14 over 5 plus 40 over 5 positive or negative? It's positive. Okay? It could be the case that sometimes you're solving these, and when you plug it in, that side's negative, so you would have to X this answer out. Okay, questions for practice on this one? Circle 11 and 12. Graphically, you'd have to graph the V graph and graph x plus 8 and see where they intersect.